What does it really mean for an AI to think? Today, we're diving deep into why. Compounding code complexity global code volume doubles every 24 months. Monorepos routinely exceed 50 million lines. AI coding assistants that only autocomplete single functions are already obsolete. Full repository understanding is the baseline for agent trust, autonomy, and any non trivial software engineering task. The industry is shifting from document retrieval to system reasoning. This isn't an optimization, it's the new table stakes. But here's where it gets interesting. Problem. Context wall. The largest production models ingest 200K tokens, less than 0.5% of a large monorepo. Naive RAG retrieves text snippets without structural awareness. Dependencies across modules vanish. Agents make destructive edits because they cannot see cross-file side effects. Worse, they hallucinate APIs and fail silently on integration. The gap between model context and repository scale is a safety and correctness ceiling that no larger window alone can fix. So, what's the real problem? Let's talk about cause. Code is a graph, not a string. A repository is a living web of function calls, type relations, import chains, and data flow paths. Treating it as flat text severs these edges. Chunking by line count destroys the semantic topology, breaking a function signature from its callers, a class from its subclasses, and agent reasoning on isolated fragments lacks any model of system behavior. Understanding requires traversing the graph, not scanning a haystack. This raises a critical question: breakthrough. Graph-Native Agentic Retrieval extract the repository's structure as a queryable, versioned knowledge graph, combine symbolic graph traversal with dense semantic vector search. The agent plans multi-hop traversals, inspects only the files that matter, and synthesizes answers grounded in architectural reality. This fusion bridges the chasm between surface text and system structure, making cross-file reasoning computationally tractable and accurate. Now let's zoom in on system. The repository intelligence stack layer 1 static analysis, AST, and compiler infrastructure extract call graphs, symbol tables, and type hierarchies. Layer 2 graph store, a version diffable dependency index, serving as the canonical source of truth. Nodes store symbol metadata and location pointers. Layer 3 contextual embedding. Code chunks are embedded together with graph proximity metadata and scope annotations, creating structure-aware vectors. Layer 4 agent orchestrator, a tool-augmented reasoning loop that plans, retrieves, reads files, and iteratively refines understanding across multiple rounds. The orchestrator employs React-style planning with graph-aware tool calls, maintaining an episodic memory of visited nodes to avoid cycles. Here's something most people overlook: conmonants, core engine primitives, graph builder, language-specific extractors that produce a unified symbol graph with incremental diff updates on commit. Handles cross-language FFI and generated code. Structure-aware chunker. Splits at function, class, and module boundaries. Never breaks a signature from its body. Preserves import context, hybrid retriever. Scores candidates by graph neighbor distance fused with vector similarity, delivering both high recall and topological relevance. Agent toolbox. Trace.proj, redfied rundips, getdiff. Each tool returns structured, graph-aware results. Chunker also tags each chunk with its graph degree, enabling triage of high-impact nodes first. Think about this for a second. Workflow. Multi-hop reasoning loop user intent is decomposed into a plan, graph queries, file inspections, and test runs. Agent retrieves candidate nodes via graph traversal, then reads the corresponding source, precisely never entire files blindly. Observations refine the active subgraph. Irrelevant paths are pruned dynamically. After each hop, the agent decides replan, dive deeper, or synthesize. The final answer includes a full provenance trace of every referenced symbol and dependency, enabling verifiability. The loop maintains a confidence score per retrieved fact, triggering re-retrieval if below threshold. And this is where things get complex. Impact. Precision, trust, scale agents now understand side effects, refactor safely, and fix bugs that span dozens of files. SW bench scores jump. Incorrect edits drop by over 60%. Large-scale changes that once required days of manual review can be proposed, verified, and merged in hours. Repository-level comprehension transforms the agent from a suggestion engine into a trusted engineering collaborator. Developer velocity compounds. Metrics show a 3x reduction in hallucinated imports and a 40% speedup in PR merge times. But here's where it gets interesting. Limitation. The cost of depth multi-hop reasoning multiplies token consumption and inference latency. Keeping the graph synchronized with live code, handling every commit, branch, and rebase remains an open systems challenge. Indexing a 10M line repository can stall fresh developer environments. Today, depth trades off against speed and freshness. We need incremental streaming and cached intelligence to remove that trade-off. Latency budgets now dominate architecture decisions. We target sub-second hop times for interactive use. So what's the real problem? Let's talk about next evolution. Incremental streaming on device. Incremental graph updates run on commit, re-indexing only changed files in milliseconds. Streaming reasoning, the agent emits tokens concurrently with graph traversal, masking latency. Small specialized models execute local graph queries offline, removing cloud dependency for routine intelligence. Colleged, pre-computed subgraphs serve hot paths instantly, cutting retrieval costs by 10x. Model routing dynamically selects the cheapest capable model per subquery. This raises a critical question: platform. Universal repo understanding one abstraction across all languages, a unified symbol graph, and semantic index. Open frameworks make repository intelligence a pluggable commodity, any agent, any IDE, any CI pipeline. The primitive layer shifts from code search to code reasoning, enabling an ecosystem where repository-aware tools are the default, not the exception. Integration surfaces for GitHub, GitLab, and local editors. Adapters for TreeSitter and ELSIF unify 30-plus languages under one schema. Now let's zoom in on vision. Self-programming software agents navigate, modify, and verify entire code bases autonomously. The repository becomes a living document that is continuously reasoned over, updated, and improved. Bug fixes, migrations, and feature additions are proposed with full system awareness. The loop from issue to merged PR shrinks to minutes. The era of repository-scale AI engineering is no longer speculative. It is here, and it is being built now. Teams will define intent, and agents will deliver tested, repo-aware implementations.